Hey, hello, greetings, greetings. We are now going to work on identifying functions. So you'll be able to look at some numbers, some relations, a table, mapping, graph, an equation, and you'll be able to identify if it's a function or not. Why is that important? Well, it helps you to identify how you're going to react to it and use it and interpret its data, right? So whatever the function gives you, you have to know that it's a function, and that'll help you determine and make claims and make some logical analyses based on if it's a function or not. Okay, so you're going to be able to determine if a relation is a function because the outputs and inputs. Here are the standards. Let's go. You're going to take a look at a couple of different ways of talking about relations and functions. First, they'll be given something called ordered pairs. Don't forget our ordered pairs are set up in such a manner that we have x and y. X is the first term, y is the second term. Don't forget what our x's are. Write them down right now. Hopefully you remembered that our x's are our independent values. They're our domain. They are the, we choose, because they're independent, they have a choice. So as independent values, they are the domain. Um, There's a couple other things I forget right now. I'm brain dead. Uh, we also have our y values, which are dependent values. It's also our range. Okay. Um, when you're dealing with your inputs, oh, it's on the x-axis, obviously. When you're dealing with your inputs, this is a mapping example. So we have our inputs, and we map them with an output. So this is an example of a what they call a function, because I take one input and measure exactly one output. The input does not go like that. I can't go to two different guys. That's not a function. That'd be bad, okay? But for this example here, this is a function because there's exactly one input for every output. Let's take a look at this table. -2 goes with 3, 1 goes with 2, 0 goes with the -1, 3 goes with 1. That's how we show it with our different relations with a table. And then obviously with the graph, here are my ordered pairs. 1, 2, I have 3, 1, 1, 2, 0, -1, and -2, 3. That's how I show it with the graph. So there's different ways of showing it with the graph, table, mapping diagram, and ordered pairs. So the relation is a set of ordered pairs. We have our inputs, which are x values, and our outputs, which are y values. It's important to note that when we have a function, it's a specific relation, okay? It's a more detailed relation. It goes to exactly one type of output. And so each input has exactly one output. So 2 only goes with 1, 4 only goes with 3, 5 goes with 4, 9 goes 7. You'll notice if it's not a function, I'll try to find if I can make red happen. So show that no, we don't want to have that at all. No, it didn't work. I can't figure this out. Input here has, oh, there we go, duh. Input goes with input of 2 goes 1 and 3. That's bad. That's some bad news. You don't want to have your input going with 2 and with 3. That means input's, messing around. Input's going 2 and 3. No, I can't have that. That's not functional. It doesn't work. 5 goes with 4, 9 goes with 7, but because of 2, it's not considered a function. So that's how you deal with the mapping diagram. If I take a look at my mapping diagram, here I have exactly 1-to-1 type of a setup here, but here this 1 goes with those two guys. Can't happen. It could go the other way. You could repeat your outputs. You just cannot repeat your inputs. Go away. So why is that doing that? Okay, go away. All right. So if I'm looking at this, I'm going to identify a function using mapping diagrams. Right now, this is definitely not a function because this input goes with two different outputs. He's hanging out with 1 and -1. We cannot have that. That's just bad, bad stuff. So that's not going to work, right? So it's not a function. That doesn't mean it's not a relation, it's not a function. Look at this guy right here. Is this a function? Yes or no? Well, 2 is only going to one output. 4 is going to -5, and 4 is also going to -7. 4 is going with two different outputs. That is not functional, okay? Because of that, the whole thing's not a function. Now, 6 and 8 could go to -11. Who cares? Outputs could have as many, we could go to so many different outputs could be shared, but you just cannot do it with inputs. Inputs you cannot put in twice. So looking at a table, same exact thing here. Look real quick and easy. If I look at my inputs, do any inputs repeat? Do any inputs repeat? Yeah, right here, right? So it's not a function because the inputs repeat. Looking over here, is that a function? Absolutely not, because of these inputs repeating. Oh, wait, hang on. Wait, no, they don't repeat at all. DocAm can't see anything. Those are negative signs. So it's a function because they do not repeat. However, we don't care if this repeats. That's okay. It just, you cannot have it repeat for the inputs. Very important distinction. Look at this one right there. Is that functional? Absolutely not. 2 repeats. You cannot have 2 repeat. 2's all over the place. 2 cannot repeat in the input side. Now, if I'm taking a look at a graph, it's super simple, and it's actually super simple. It's called a vertical line test. So if I take any of my points, let's say I had, this one here. If I take a straight line, I use a pencil. I call it a bonk test. If I could take a straight line, and if my straight line, my little crosshairs here, hits more than one point as it goes along, it will, I'll do the bonk test with you guys in class. So, but essentially, if I take a vertical line and go straight across and it hits more than one point, it's not considered a function. This case here, if I draw a vertical line, oh my God, that totally fails a vertical line test, doesn't it? It hits this guy here, it's this guy here, this guy here hits this guy here. So I get 2 points there, so it's not a function. It's not functional. X cannot repeat. If I were to write a table for this, I would see that at 1, X hits a guy here, and X hits a guy here. They're sharing 1. You can't do that. Is this a function? Well, if I draw my vertical line test, let's see, vertical line, vertical line, vertical. Yeah, it's a function. It's a goofy looking function. It's called a parabola, but it definitely is a function. It still works. I have to pause and reflect. Nothing. All right. Example 3. I'm looking at this stuff here. Is this a function? Can I do my vertical line test? Only hit 1 point. Only hit 1 point. Only. Right there. Yep, that's hitting 2 right there. That's bad. That's bad. That is not a function. Okay, that is not a function. So I hit 2 of those guys right there. Not bad. Not good. It's not a function. Is this a function? Let's see. Line, 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 line. It's a function. It doesn't bonk at all. That'd be the bonk, but you'll hear the bonk when you say in class. That's going to be the phrase that pays. DocM, show us the bonk test. DocM. Vertical line test. That's the phrase that pays. It's got to be on that spot, 259. Okay. Here I have these guys here. From looking at this, is it a function? Oh, vertical line test. Yeah, it doesn't bonk ever. Nope, nope, nope. We're good there. What about here? Holy cow, I'm bonking all over the place, right? Yeah, definitely not a function. That other one is. So that's what you have to do for this particular module. Easy cheesy, lemon squeezy.